All right, now it's recording.
Okay, do you know where it stopped?
No, it doesn't tell me where, so you have to just do it all over again.
That's shocking.
Oh, okay. All right, back to the corrupted file. Okay, so for this exercise, we write a program that reads 20 float values from a file. The values are stored in vector or one-dimensional array. So you find the smallest, the second smallest, and the third smallest of the set. So that's what I have written up here, just commented out so I can see it easier. So then I include standard input output, standard library, and string.h because we use functions that are in those ones. Define the length to be 32. I could have done less because there's only 20 values and there's only 20 float values, so I could have done less. So now to the main file, you just open the file, or like you define the file, you define input file as a file, you define I as an integer, then you want the string length to be a float value because you're searching for floats from here from the input file. And then I set float as the minimum to be 100,000, the second minimum to be 100,000, and the third minimum to be 100,000. So here, with the input file, if you want to have it open, you want to open the input file as in read mode because you're just reading from it. And so, but if it equals null, then it can't be opened and you exit with an error. Okay, so to scan the value from the input file, you want to set a for loop that starts at I equals 0, goes to I is less than 20, and it increments by 1. So you scan the input file for a float, and you want to have, we're looking for the string of I. So it's just, yeah. And then, but you want to make sure you put this ampersand here because, or else it won't scan right if it's not, unless it's a character, it doesn't, you need the ampersand. Then this print here is just to help visualize it when you run it, what it looks like. So for this for loop, you start off the same way by having for and I equals 0, I is less than 20, and I plus plus. So if the string of I is less than minimum, you set this value, the second minimum to the third minimum, the minimum to the second minimum, and the string value that you get of in place I as the minimum, the float value, into the minimum. But if the string of I is not less than the minimum, you check if the string of I is less than the second minimum. If so, you set the second minimum value equal to the third minimum, and you set this new float value you look for from string of I to the second minimum. But again, if it's not less than the value of the second minimum, you check if it's the value of the third minimum. So if it's the third minimum, it stores the value of string, the float value of string I as the third minimum. And so then that's the end of the for loop. This is just a failed code that I had for it earlier. So it runs this for 20 float values. And then from down here, you just print out the smallest, the second smallest, and the third smallest. So here's the input file. It has five columns, 4 rows, I think. So it's just 20 in total. And so it looks for each one of these when it scans. So to see what it looks like, let me execute compile. Let's run it. So here's this print. This is where I just printed it to help me look at it, visualize it. And then, so the smallest would be the -4.64. The second smallest is -3.73. the third smallest is negative 3.58. And if we check the input file, this is the smallest, this is the second smallest, and this is the third smallest. And so to help explain this a little better through examples, we can look through here. So if the float value string I is less than the minimum, so value 3.14 is less than the minimum, which the minimum is 100,000. So yes, it's less than the minimum. So then the second minimum is stored here, the minimum is stored here, and then this value, the 3.14, is stored as the minimum. And so then it goes through it again, but now it's I equals 1. So then this is the value, this value. So you check 4.05. Is 4.05 less than the minimum? No, because the minimum is 3.14. So you check, okay, is 4.05 less than the second minimum, which is 100,000 right there? It is. So then you store this value here, and then you store the 4.05 as the second minimum. And then for the next example, you loop through it again, but now I equals 2. So if string of 2, which is negative 3.75, is it less than the minimum? Yes, it is less than the minimum because the minimum is 3.14. So now the minimum, the second minimum, which is 4.05, is stored as the third minimum because it moved down because something takes its spot underneath it. The minimum, which was 3.14, is now in the second minimum spot because, again, there's something underneath it that's even smaller, so it moves everything up. And so then this value is stored as the minimum. So it runs through this for all 20 of these float values in the file. And so it does that and checks which one's the smallest and not and whatnot. So and then it down here it prints it. And I chose these values because they're really large, so that there's not a lot of chances that the values from the input file are greater than it, so that it would always be the minimum. There's never a chance that it's higher than the minimum.
Can you try some real quick?
Yeah.
Can you include in the actual? Can you include math.h, and then for your float minimum, min 2, min 3, I think you could just type infinity, like in all caps, and it like registers or recognizes that as like a infinite value. I don't know if it'll work or not. Okay, try FLT underscore max then.
For what?
FLT underscore max in all caps.
FLT underscore max?
Yeah. Yeah. No? Okay. Never mind.
All right, well, either way, you can choose higher numbers than 100,000. It doesn't matter. It's just what numbers I chose because.
Oh, no, leave it as FLT max, but include float.h.
Oh. Okay.
And math.h. You
Float?
need them both, I think.
Oh, what's it called?
Float.h. Okay, I think that float underscore max is the largest value that a float value can be, like in the bitwise version.
All right, so yeah, that's perfect. So this just makes it so that there's no way that the float value that you get from the input file is less than this number. So that's what this is for. And that's it. That's this code. Anyone have any questions?
That makes sense.
Okay, cool.